For this video, we're going to talk about approximating the mean with grouped data. We've already spoken about the mean for if we have the raw data, but sometimes we don't have the raw data. Sometimes we are given just the frequency distribution. And so we have to learn how to calculate or approximate the mean using a frequency distribution. And so what we're going to do is we're going to discuss the steps, which in this case, step 1 is to compute the midpoint of each class. This x sub m, an x with a subscript of m, that's literally what it means. It means the class midpoint. Recall that the class midpoint is the lower class limit plus the lower class limit of the next class. And then we divide by 2. Once we have the midpoint for each class, we're going to multiply the class midpoint by the class frequency for each class. That means we're going to take the x sub m, the class midpoint, multiply it by the f, or the frequency. Step 3, we're going to add up all the products of the midpoint and the frequency over all the classes. So in other words, those numbers that we got in step 2, we're going to add those up. And in step 4, we're going to divide that sum that we received in step 3 and divide it by the sum of the frequencies. So we're going to add up all the frequencies. When we add up all the frequencies, that is our n, our sample size. And so when we look at this, we're following these steps and we're still dividing by that n to get our mean. What we're having to do is we're having to approximate what the values are in that class. And so we're just taking the class midpoint and then multiplying it by how many are in that class is what we're doing. So let's look at an example. We have miles run per week. So using the following frequency distribution, find the mean. The data represent the number of miles run during 1 week for a sample of 20 runners. So we have these classes set up, and if we look at these classes, notice that the class width is 5, because that is the difference between the lower limits. So 11 minus 6 is 5, 16 minus 11 is 5. And you can also see that on the upper limits, their difference is 5 as well. So the class width is 5. We're also given the frequency. So there's one number that's in here in this 6 to 10. It could be a 6, it could be a 10, could be a 7, 8, or 9. We don't know. We're just told that there's one number between here. Same thing happens with the 11 to 15 class. We have 2 of them. They could both be 11s, they could both be 15s, one could be an 11, one could be a 15. We don't have a clue. And so that's why we can approximate this. But how we have to approximate it is first find those midpoints. And it's much easier if you set it up in a table like this, having the class, then the midpoint, and the frequency, and remember we have to take the midpoint times the frequency. So if you have a table set up like this, the calculation of the mean will be much simpler. So let's look at calculating first the midpoint. So the midpoint of the first class is going to be 6 plus the lower limit of the next class, which is 11, and I'm going to divide by 2. So 6 plus 11 gives me 17. 17 divided by 2 is 8.5. And I'm going to do that all the way down. So the midpoint of the next one is 11 plus 16, and I'll divide it by 2. So 11 plus 16 is 27, divided by 2 will give me 13.5. And we keep calculating, and we get that the midpoints are going to be 8.5 13.5, 18.5, 23.5, 28.5, 33.5, and 38.5. This last midpoint, notice I have 36. I don't have the next number. So the midpoint there is going to be 36 plus what the next class should start at. So if this class ended at 40, the next class will start at 41. And so I'm going to take 36 plus 41 and divide by 2. And that gives me my 38.5. So I have my midpoints. So at this point I kind of ignore this first column, the class column, and I'm just going to use the midpoint and the frequency. So I'm going to come over here and I'm going to take my midpoint, which is 8.5, and I'm going to multiply it by 1 and get 8.5. I'll do the same thing on the next class. My midpoint is 13.5, and multiply it by the frequency of 2, and I'll get 27. And as I continue down, I'm going to get 55.5, 23.5 times 5 is going to give me 117.5, 28.5 times 4 will give me 114, 33.5 times 3 will give me 100.5, and 38.5 times 2 will give me 77. So now I have the midpoints, I have the classes, I have the frequency, I also have midpoint times frequency. So now what I need to do is I need to find out how many total data points do I have? And that's the sum of this frequency column, because that tells me that I have 1 data point here, 2 data points here, so that gives me 3. And then I add another 3, which would give me 6, plus 5 would give me 11, plus 4 would give me 15, plus 3 would give me 18, plus 2 would give me that n is equal to 20, which, if you recall from the actual original problem, it said that we had a sample of 20 runners. So that should be my n, I would hope. Now I have taken the midpoint times the frequency. I'm going to add those up, and I'm going to get that sum. And when I add those up, I should get 500. 8.5 plus 27 plus 55.5 plus 117.5 plus 114 plus 100.5 plus 77. And I should get a sum of 500. This was a sample. Anytime that you have a frequency distribution, it will be a sample. And so my sample mean is going to be my 500, which is the midpoint times frequency column added up, divided by my n, which in this case is 20. So my mean is approximately 25. So the mean number of miles run during 1 week is 25 miles. So especially for these, you will definitely want to practice. Make sure you add in those extra columns and everything. And if you have questions, let me know.